This is the topic 4 review worksheet for our topic 4 test coming up. And so first question, we have y equals 2x plus 2 and y equals x. So this is already set up for substitution. Okay, that focus. Let me make sure that's focused. There we go. And by substitution, we can just set these two equations equal to each other. 2x plus 2 equals x. So I would subtract 2x from both sides, and I get 2 is minus x. So x is negative 2. And then it's very simple. It says up here that y equals x. So if x is negative 2, y is negative 2. So these lines intersect at the point negative 2, negative 2. And that's it. Y equals 2/3 x plus 2. And y equals, or no, it's not y equals, it's negative 2x plus 3y equals 6. This too is set up for substitution. So I am going to take what y equals up here and substitute it in there. So I'll have negative 2x plus 3 times the quantity, 2/3 x plus 2 equals 6. And the reason I opted to not get rid of the fraction in that upper one and get it in standard form and use elimination is because I knew that when I plugged it into the bottom equation, when I distribute this 3, it's going to take care of that fraction. Okay, so I'm going to get plus 2x and then distribute over to here, plus 6 equals 6. Notice that the x's drop out. I get 6 equals 6, which is a true statement. So this system of equation, they are coinciding, but that's not my answer. My answer is infinitely many solutions. Okay. Number 3, we have y equals 3/2 x plus 5/4 and negative 2x plus 8y equals negative 25. And again, when I plug in that value, that equation for y in the bottom equation, it's going to take care of the fractions for me. So it's set up for substitution. Negative 2x plus 8 times the quantity, 3/2 x plus 5/4 equals negative 25. And I get negative 2x plus 8 times 3/2 is 12, plus 8 times 5/4 is 10. Okay. Negative 2x plus 12x is 10x plus 10 equals negative 25. Subtract 10 from both sides. 10x equals negative 35. So x is negative 35 over 10, which reduces to negative 7/2. Okay. So now I'm going to take that negative 7/2 and I'm going to plug it into this equation. Okay. Y equals 3/2 times negative 7/2 plus 5/4. I get negative 21 over 4 plus 5 over 4 is negative 16 over 4. Negative 16 over 4 is negative 4. Okay, so where do these two lines intersect? They intersect at negative 7/2, negative 4. Number 3. We're on number 4. We have 2x plus 5y equals 20. And we have y equals negative 2/5 x minus 1. Set up for substitution. And actually, if I use substitution, plus 5 times the quantity, the 5 outside the parentheses is going to take care of that fraction for me. Okay? Doesn't mean I'm not going to have a fraction in my answer. I might, but we'll see. So let's see. 2x, distribute here. I get minus 2x, distribute minus 5 equals 20. The 2x's drop out. It's okay. I get negative 5 equals 20, which is not true. Negative 5 doesn't equal 20. Sorry to say. So there is no solution. These lines are parallel. So sad. Okay, number 5. 2x plus 5y equals 14. And x plus 3y equals 16. So looking at that, I need to get a plan. Obviously not set up for substitution. So I'm going to try to use elimination. And so I'm going to drop out the x's. So this needs to be a negative 2, which means I need to multiply this by negative 2. And I get negative 2x minus 6y equals negative 32. And then I'm going to rewrite that top equation underneath it. And I get that minus y equals, oh my goodness, let's see, negative 18. Okay. And so y is 18. And I'm going to plug that into the second equation. X plus 3 times y, which is 18, equals 16. X plus 54 equals 16. So x is 16 minus 54. I'm going to go to my trusty calculator for this one. 16 minus 54, and I get negative 38. So these two lines intersect at the point negative 38, comma 18. Good thing we didn't have to use the graphing method. That could have taken up a lot of paper. Number 6, 3x plus 2y equals negative 5. And 2x plus 3y equals 5. So set up for elimination. I'm going to eliminate the x's. Doesn't really matter. I would get the same common multiple. So I'm going to multiply this top equation by 2. I'm going to multiply the bottom equation by negative 3. So I get 6x plus 4y equals negative 10. And I get negative 6x minus 9y equals negative 15. Okay. So x's drop out. I get negative 5y equals negative 25. Divide by negative 5. Y equals 5. Doesn't matter where I plug that in. I'm going to plug it into this bottom one since it's handy right there. 2x plus 3 times 5 equals 5. 2x plus 15 equals 5. Subtract 15 from both sides. We get 2x equals negative 10. Divide both sides by 2. And x is negative 5. So these two lines intersect at the point negative 5, 5. And number 7. Covered it up. 5x plus 2y equals 9. 5x plus 2y equals 9. And 4x minus 3y equals 44. It's an odd combination. I'm going to drop out the y's because this one's already positive and that one's already negative. So I'm going to multiply this equation by 3. 15x plus 6y equals 27. I'm going to multiply this equation by 2. 8x minus 6y equals 88. So 23x could get ugly. 27 plus 88 is 115. If you hear a ball dropping to the floor, that's my black lab Maya. She has her fetching ball and she's dropping it by my chair to remind me that she has her fetching ball, and if I were so inclined, we could maybe go outside and play fetch. But unfortunately, I'm sitting here making this video, and we're not doing that, Maya. Okay, you go play. All right, is 115, the big question here, is 115 divisible by 23? And cha-ching, it is. Tell us what we won. Well, we don't have to deal with any fractions. That's what we won. And I'm just going to plug that into that bottom equation like I did before on the other one. 4x is 5 minus 3y. See, that's 20. And then subtract 20 from both sides. So negative 3y is 24. Divide both sides by negative 3, and y is negative 8. So our answer, these lines intersect at 5, negative 8. 3 problems to go. Number 8, collection of 36 dimes and quarters. So, like we've talked about in class, these are number value total problems. So you're going to write an equation that represents the number of items you have, and then an equation to represent their value. So I have 36 dimes and quarters. So dimes plus quarters is 36. And they are worth $5.70. So that means that a dime is worth 10, a quarter is worth 25, and that equals 570. Also remember that we did these without decimal places, and it makes it a little bit easier in the end. So I'm going to multiply this equation, the first one, by negative 10, and get negative 10d minus 10q, you're welcome, equals negative 360. Okay, so I add those together, I get 15q equals 570 minus 360 to 10, then divide by 15, and the quarters is 14. So I have 14 quarters, and then 36 minus 14, I have 22 dimes. And it asks how many dimes and quarters are there, so it's asking how much of each one. Okay. Number 9, the price of 6 slices of pizza and 4 drinks is $37. The price of 4 slices of pizza and 6 drinks is $33. Okay. Obviously, we're not going to Little Caesars here. So get a plan. I'm going to drop out. It doesn't matter. They're opposites, or they're so I'm gonna drop out the P's. Okay. So I'm gonna multiply this by 2, and I'm gonna multiply this by -3. Okay. So this gets me 12p plus 8d equals 74. And the other one gives me -12p minus 18d equals -99. So when I add them together, I get -10d equals, all right, 25. So D is, that's -25. D is 250. So drinks cost 250. And the question asks, how much does 1 drink and 1 slice of pizza cost? So drinks, 250. And pizza. Let's plug that in right here. So let's do 4p plus 6 times 2.5. So 6 times 2.5 is 15. Take 33 minus 15, and we get 18. And 18 divided by 4 is 450. So a slice of pizza costs 450. Okay. And it's saying, what is the price for 1 drink and 1 slice of pizza? So, do they want that added together? I would put both just to make sure. So 450 plus 250 is $7 for 1 drink and 1 slice. Okay. And then the next one is one where we're going to have an equation for the number of tickets, or the number of people, and then an equation for the value. No, we're not. I lied. Same as the last one, where we have 4 adult tickets plus 3 child tickets is $156, and 3 adult tickets plus 4 child tickets is $145. Okay, and what is the price for 1 child and 1 adult? So I'm going to drop out the adults. So I'm going to multiply this equation by 3 and multiply this equation by -4. So 12a plus 9c equals 156 times 3 is 468. And -12a minus 12c equals -580. We add those together, the a's drop out. I get -3c equals -112. And so I'm getting a not nice number. It's 112/3, or children be $37.33. Did I write something down wrong? Because it should come out, I mean, it could come out like as a quarter, but usually we wouldn't have it come out as a repeating decimal. 4 adults, 3 children, 3 children, 4 adults. Wait. No, 3 adults, 4 children. 4 adults, 3 children. No, I think it's just going to come out weird. So what I'm going to do now is I'm going to drop out the C's to solve for the adults. So I'm going to turn around and I'm going to multiply by the top equation by 4 and the other equation by -3. And that'll give me 16a plus 12c equals 624. And -9a minus 12c equals -435. So 7a equals 189. And I get that A is 27. So the adult tickets are $27. Onward and upward. Supposed to graph y is greater than 3x plus 3. So I don't have any fancy schmancy graph paper in here. So y-intercept is 3, slope is 3, so I'm going to rise -3 and run +1. No. Yes. That's a positive slope. Down 3 left, and it's a dotted line. And if I plug in the origin, I get 0 is greater than 3. Not true. So shade away from the origin. My answer is above the line here. And then number 12, we have x minus y less than or equal to 1. We have x plus 2y is less than 4. And I'm going to change these out of standard form. I'm going to put them in slope-intercept form. So for that first one, that helps. Let it recalibrate here. That might help a little bit. I'm not sure. It's getting dark. So I'm going to move x to the other side. So that's going to give me minus y less than or equal to minus x plus 1. And then I need to divide through by a negative. So y multiplying or dividing by a negative means I flip that inequality. Is greater than or equal to x minus 1. Okay. Here I'm going to have 2y is less than minus x plus 4. And then divide everything by 2. So -1/2 x plus 2. And then graph them on the same coordinate plane to find out where they intersect. So one on the left, the y-intercept is -1, and the slope is 1. And it is a solid line. And 0 is greater, it's going to be shaded above, right? Okay, just real lightly mark that in. The other one, the y-intercept is at 2, and the slope is -1/2, so I'm going to rise and run, and that is a dotted line. And 0 is less than 2. It's going to get shaded this way. Where do the shadings overlap? Shadings overlap in this triangle. Okay. That's it for that one.